Hey, it's Professor Gould. In this next video, we're going to talk about blood types. I warn you, it's a little bit confusing. All right, so there are two main blood typing systems. So the first is A, B, and O, and the second is what we call the rhesus typing system, which is the positive or negative, okay? So if you're O negative, you have O type of one blood typing system and then negative in the rhesus typing system, okay? These are both genetically determined. You have two copies of the gene that is responsible for this typing, and so you can either have type A, type B, type AB, or type O. And then for all of those, you can either be positive or negative. Okay, so we're going to talk first about the ABO typing, and then I'll talk briefly about the rhesus typing. All right, so both of these typing systems are based on the presence of antigens on the erythrocytes and antibodies in the plasma. Okay, what do these terms mean? All right, so an antigen is anything that causes a reaction from your immune system. So anti meaning against and gen meaning creation. So it creates a reaction against itself. Especially, these are molecules that an antibody can react to or can bind to. And so in these blood typing systems, the antigens we're going to look at are molecules on the surface of the red blood cells that antibodies can bind to. The antibodies are these proteins. That's a Y-shaped protein. These are some of the proteins that circulate in the blood plasma. And what they do is each antibody has a special binding site on these green ends that bind to a specific antigen, and then the other end binds to a white blood cell. So they can bind to two different antigens at once, basically bunching them up so that they can't do whatever it is they are supposed to do. They can also, by binding to the white blood cells, they can initiate phagocytosis by the white blood cell. So the white blood cell binds to this, engulfs the whole thing, including the antigen, which is a pathogen potentially. And then that starts a whole other immune reaction that we will come back to when we do the lymphatic system. Okay, so we've got antigens, which are the molecules on the red blood cells, antibodies, which are proteins circulating in the blood plasma. Okay, so let's look at the ABO blood types. So here are blood types. We've got type A, type B, type AB, and type O. And then this is what the red blood cells look like, the erythrocytes. These are the antibodies in the blood plasma. So if you have type A blood, then you have this round, we're just going to call it round. Okay, I don't actually know what shape it is. It doesn't matter. You have this A antigen, and then your plasma has these antibodies that bind to these little triangles. So these antibodies can't bind to your blood cells. Everything's fine. Okay? If you're B, you have little triangular antigens, and your blood has these antibodies that bind to the little round things. And as long as, you know, these are in blood together, it's fine because this can't bind to the little triangles. Now, if you have type AB blood, you actually have both antigens, the round ones and the triangles, on your red blood cells, and you have no antibodies in your blood plasma. If you have type O red blood cells, you don't have any antigens, but you have both antibodies in your plasma. Okay, so as long as the blood going through your body is the normal type, everything's fine. And if you get a blood transfusion of the same blood type, everything's fine. You get the same red blood cells and you get the same antibodies and nothing binds with anything and everything is totally fine. Now, if you have type A blood and you get an infusion of type B blood, then we have two problems that can happen. One is that your antibodies can bind to the type B B blood cells. And the other is that the antibodies in the type B blood will bind to your type A red blood cells. So this is what happens. So here we have blood from a type A donor going into a type B recipient. So the antibodies in the type B blood bind to the A red blood cells. And remember, the antibody can bind to two things. So it actually binds the two red blood cells together. And that causes what we call agglutination, or a clumping. And when we test blood types, we actually can see this clumping happen. So when no agglutination is happening, the blood stays, nice and even. When agglutination happens, the blood clumps up, and that's really bad for blood trying to go through your bloodstream. And in fact, it will kill you. Okay, so let's go back to this. Now, one of the other stories I love to tell while I'm giving this lecture is about the man who first discovered that blood types were a thing. He had no idea what was going on. He didn't know anything about all of this molecular level stuff. He just figured out that you can't necessarily mix blood from one individual with blood from another individual. And his name was Willis. He was working in the, I want to say late 1700s. I really need to look that up. Don't quote me on that. And he is actually famous for discovering the blood circulation through the brain. And there's a thing called the circle of Willis on the bottom of the brain that he figured out how it works. He did a bunch of experiments on dogs. So keep in mind, this was a long time ago when there were tons of stray dogs and, not as many people caring about animal welfare. And as far as I could tell from reading about him, he just gathered up stray dogs and did experiments on them. So one of the experiments he did was he took one dog and he took blood from it and he injected the blood into another dog. And the first time he did the experiment, it worked. Both dogs were perfectly healthy. And he was like, oh my gosh, this is the coolest thing. If we can do this on humans, this would be amazing. We could, if somebody has lost blood from an accident, we could actually give them somebody else's blood. This would be life-saving. So he gathers all of his friends together, his science friends, and he's like, you guys are not going to believe what I discovered. Watch this. So while everyone is watching, he takes a sample of blood from a dog. He injects it into another dog, and the second dog dies. And he's like, that's not what happened last time. So he tries again. He does it again with a new pair of dogs. The recipient dog dies. He goes, okay, well, it worked once. I did it with these other two dogs, and it totally worked. So everybody's like, sure, whatever, dude. It takes a really long time after that before they figured out what was actually happening. But he was the first one who was like, guys, look, check out what happens. And he accidentally discovered that there were types of blood. Anyway, that was Willis. Please don't do experiments on dogs unless you really need to. Thank you. Okay, so anyway, fast forward, we now understand antigens and antibodies, and we can do blood transfusions from one person to another. So now I want you to look at this chart and think about antigens, antibodies, agglutination, all of that. And I want you to think about, I'm sure you've heard that people who have type O blood are the universal blood donors, because they say that you can take type O blood and you can give it to anyone else. Is that actually correct based on what this chart shows? If you think about it for a moment, you have to realize it's not. If you give type O blood plasma to anyone else with any other blood type, they have the antibodies to bind to every other blood cell. You can't give their plasma to anybody but a type O recipient. Type O is the universal red blood cell donor. And that's really important because we can't make red blood cells in a lab. We figured out how to make a bunch of tissues in the lab, but we cannot make red blood cells in the lab. The only way we can get them is from donors. So if you are a type O person in particular, give blood if you can. It's very, very important, and it really is life-saving. Okay, so O is our universal red blood cell donor. Now look at this chart and figure out why type AB donors are also super important. If you look for a moment, you can see type AB doesn't have any antibodies in their plasma. So you can give AB plasma to anyone. So type AB blood plasma is really, really valuable. If you have type AB blood, you can actually sell your plasma. Actually, anybody can sell their plasma, but AB is very valuable. And while you can only give red blood cells about every 8 weeks, or excuse me, every 8 weeks, you can't give less than 8 weeks, you can give plasma every few days. And certain blood banks will actually pay for plasma. So if you're really, really desperate for money, or you really want to help people, you can sell your blood plasma. So there you go. All right, now you're still wondering about positive and negative, aren't you? Okay, so if you are positive, then you have an antigen on your red blood cells and no antibodies. Easy peasy, no problem. If you're negative, you don't have antigens on your red blood cells, and you also don't have antibodies. So who cares? The problem is the second half. You don't have antibodies unless you've been exposed to positive blood. So how would you get exposed to positive blood? Well, the most common way is in pregnancy. So in a first pregnancy, if the mom has negative blood and the fetus has positive blood, then the fetus, even though the red blood cells don't circulate through the mother's blood plasma, the plasma can be exchanged. And the mother's blood can start making antibodies to the positive antigen. Now, in the first pregnancy, it's actually not going to be a problem. What happens is if the mother has a second pregnancy and a second positive blood type baby, in which case the mom's blood will have antibodies to the positive blood of the fetus, and that can cause agglutination in the fetus, and the baby can be born with what they call a blue baby syndrome, which is the baby's blood isn't circulating correctly. We now can give a drug to moms who have negative blood so that their blood doesn't make these antibodies, and we prevent that. So that's blood typing, okay? It has to do with the antigens on the red blood cells, the antibodies in the plasma. So remember that type O is the universal red blood cell donor, no antigens. AB is the universal plasma donor, no antibodies. Positive blood has no antibodies. Negative blood usually has no antibodies. All right, so that's your blood types. That's your agglutination. And this next lecture, we'll talk about the Buffy coat.